Hello, my name is fmckenna. I'm here at UC Berkeley working for the Near East Sim Center. This is a short video showing you how to define and use functions in your C programs. Why would we want to use functions? Well, the whole art of programming is we've got a problem and we keep dividing it, breaking it into tasks and breaking those tasks into tasks until eventually we've come up with the instructions write themselves. It's so simple to write them once we keep breaking it and breaking it down. Now, for large projects, we do not put all the code inside a single main block. We break it up into logical, meaningful blocks of code. In object-oriented programming, we call these blocks classes. In C, these blocks are functions, sometimes called procedures. Functions make large programs manageable. They're easier to understand. They allow for code reuse, allowed to be developed by teams of programmers. I could go on infinitum about the advantages of using functions in programs. If you don't write functions and when you're writing a large program, you're an idiot. No other way to say it. So let's talk about what a function looks like. So the function name is, here's the function here. So it has a return type. What's the value it's going to return? Is it an integer or a double? Does it return nothing? Nothing is a void. Function name, what is the name? When we use it in the program, are we going to invoke it with? So that's our function name. Each function takes a number of arguments. What are the specific arguments for the function? And then inside the curly braces, you would then define the code block for the function, the code that actually implements that function. So here's an example function, simple function, sum an array, which will sum an integer array. So the array is coming in as a pointer, int pointer data, and int pointer size. The result of some array is going to be some integer. So the code block, which is inside the curly braces, I'm going to define a variable sum into sum. I'm going to loop over the array and put each component. I'm going to add each component to sum, and then finally when I'm done, I'm going to return sum. And this is how I'd use it in my main function. I define int array size 6, I initialize it with some values, and then I invoke the function with my array and the number of values in the array, and then finally I spit out the result. I could rewrite this a little bit differently with pointers, which we'll do a little bit get tomorrow. So hopefully I don't confuse you with this, but I could say sum plus equals star data plus plus. So what this does is basically loops over the array. It takes whatever the value data is currently pointing to, adds it to sum, and then it increments that data pointer. It increments that by the size of in this case, an integer. And this is all possible because this is passed by value as opposed to passed by reference. Again, we'll deal with this tomorrow, so don't worry too much if you don't understand this, but we're going to see a lot of this tomorrow. This is not the best style of code. Remember, when we write C code, we kind of keep to a common style, and most programmers wouldn't write code like that. They'd write it more like this. The main function is typically, or most always, the first function you find in a C program. So it's easy to find, everybody knows where it's going to be. So any functions that you have in that main.c file are typically placed after the main function. So we're placing it after the main function. Now the problem when doing with this, if I was to compile this code, it would give me an error because it doesn't know what sum array is. Because sum array, the compiler hasn't come across it yet. So to fix that, you include a line at the top of the file that looks like this. So you define a function prototype, and you basically say here's the function prototype. Typically you just copy this, paste it up here and add a semicolon. But it basically defines that sum array is some function that's coming along. You'll see it in a bit. It's int pointer int and it returns an int. So you're just telling the compiler this is coming along. You'll see it in a minute. Now this is not quite how a good C programmer would do it. What he would do is he would add information about what these are. The compiler doesn't care, but the user who actually uses these functions will care, because this will save him having to, him or her having to go to the end into the file somewhere to find out, well, just exactly what are all these arguments that are passed in the function. Well, this one is pretty obvious what they must be. For large functions, it is much easier to see what these values are if you give them meaningful names in the function prototype. Now, speaking of good practice, when we write large programs, it's a good idea to break up our functions. We put the functions in logical units. For example, we'll create a file and put all the functions that deal with vectors in one file, another file with functions that deal with matrices. For each of these files, we'll create another file, a .h file, in which we'll have function prototypes for all the functions that exist in the .c file. And then finally, we will document what the functions take in the .h file so people don't have to open up the .c file just to see what the arguments are for the functions. So here is an example, my vector.h and my vector.c. So I've defined a file, my vector.c. In that file, I put all the possible vector operations I might want to use in my program. In my vector.h, I define the function prototypes for all those vectors. And then when I want to use it in my main program, this is what my main program is going to look like. This is a main program that's going to arbitrarily create two random vectors of certain size that you're going to pass in the input and produce which one am I doing? I'm just doing a dot sum of the two vectors. So here's the main. This is the main function. To include in my function prototype, I've now got include my vector.h. We haven't seen this before, but now I'm actually using argc and argv. So I want to make sure argc is size 3, that way the user has called it with the correct inputs. So if they don't input 3 arguments, I'm going to give them a little error message and return a negative value, so I don't always return 0. Return 0 is the default that the program was a success. If I return something else, it's an error. And applications that actually invoke these applications will know that the application returned an error. So from the command line, from this argv, I'm going to get n in maxval using the functions a2i on argv1 and a2f on argv2, which will return a floating point and an integer of this character pointer. Note 1 and 2, app name is actually argv0. Sometimes the application wants to know whatever application name you gave it. Then we are going to create 2 vectors, or create 3 vectors, each of size n. We're going to randomly fill those vectors with numbers between 0 and maxval. Then I'm going to print out the 2 vectors. I'm going to do the dot sum of my vector, and then when I'm done, I'm going to print the result. So that is now what a C program looks like, which does an awful lot of stuff, and it shows how easy it is to implement when you actually, break these things up and put the vectors in other files. And then other programs that are used that also use vectors can then just use this file without having to rewrite the code in those files. And when I do that, I typically, I'll start adding new functions to my vector.h and my vector.c every time I come up with a new program and the function I want isn't actually there. Scope of variables. Scope of variables in C is the same as in Python. Here's an example. I've defined x in multiple places. So int x outside of main makes it a global variable. Any function that's defined in scope1.c can actually see what x is, even though it's not passed. It doesn't exist inside the function, so this is a global variable. Inside x, I'm going to define a function, and inside the body of this if statement, I'm also going to define another variable x. So I've got variable x defined in 3 locations. So what is the result of this program? So line 5, x equals 20. I'm right here. Basically, this is the only x I see. It's the one in the global scope. So x is going to be 20. Line 8, I've just defined x inside main. So I'm going to see x is now 5 because that's what I defined it to be. Inside the if statement, I'm in line 12. So if I see x here, it's going to be what's the variable inside that body of that if statement. So that's x, currently x equals to 10. Now I'm outside the if statement. I go back to my original one, which is x equals to 5. So next pops up is line 21. So line 21 is coming because I've invoked sum. Line 21, here we have sum. So the x, it's not inside, it's not as a variable argument, it's not defined in here. So what x is going to print out is this global variable. So that's that 20. And then finally 17, I've just changed x here. I've made it now x plus x, which is 10. So now seeing that now x is 10. So another thing in C programs that are somewhat different to other programs is that all arguments are passed by value in C as opposed to passed by reference. What this means is that if you want to change something other than a pointer inside a function, let's look at this function down here, this void sum int. If I want to change something inside this thing, I have to pass a pointer to it, because otherwise it's just being passed the value. So if I was just passing int sum here, it would pass whatever just happens to be inside sum. But if I want to change it, I have to pass a pointer to sum. So when I do this star sum equals a plus b, it will actually change sum to be equal to the result of whatever input is. And if you want to try this yourself, run it with, take out the star here, run it, print out what sum is here, and you'll see that sum is equals to 0 if I change this. So again, this allows me to change the value of sum inside the function. Why I'm showing this for a very simple problem? Well, typically a simple problem like this where it just returns one value, you'd have it as the return type. But for procedures or functions in which you want to change multiple values or multiple variables inside the function, you need to do this. You pass them all in as pointers, and it's also good practice, speaking of good practice, to specify all the values that don't change first and then put all the pointers last. That's the standard way of defining such functions. Speaking of functions, there's a whole bunch of mathematical functions that exist. They're not actually by default in the program when you start running it. To include the math functions, we need to include math.h, and then once we have included math.h, we can start using the mathematical functions. And sometimes you have to link with a -lm flag to get the mathematical library included. Some compilers will do it by default, but again, good practice if you write code you want to be portable and you develop what are called makefiles, you want to push -lm in your makefile. Now recursion, we've seen recursion in Python. I'm not sure if Peter did it with a factorial, but this is an example of recursion. Recursion is where the function calls itself multiple times until such a point it comes to an end. So in this case, we're going to do factorial. I showed you how to do factorial in a for loop and a while loop in the previous video. So here's how we do factorial inside a function using recursion. So basically, the function calls itself with the value of n-1, and basically we break out of that loop by returning 1 when n does equals to 1. And this is how we'd use factorial in the main program. So here's a little simple exercise if you're interested, where we're going to sum up. We're going to write a little procedure, copy this, write a little procedure that just returns the sum of a plus b. It should be trivial for you at this stage.